Hello guys, welcome to my YouTube channel. Today we are going to discuss about symmetrical components. In a symmetrical components, we have three types of symmetrical components, and we have a sequence, we have a positive sequence, and we have a negative sequence. We can note them down. We have one is what we known as zero sequence, two we have negative sequence, and three we have a positive sequence. This is in a three phase. You have a zero sequence, negative sequence, and positive sequence. Another thing we can note that in a three phase unsymmetrical fault, we have three types of fault that occurs. We have a single line to ground fault. You can see here. Let's demonstrate. This is what we know as three-phase line. We have red phase, yellow phase, and the blue phase. First fault, this is the ground. We have three types of fault in a three-phase. The first fault is a single line to ground. Let's say this one is our blue phase. It's a single line to ground. That is a single line to ground fault. We have another fault known as line to line fault. You see, these are red phase, these are blue phase. A line to line fault, these are a line to line fault. And we have the last one is what we know as a double line to ground fault. These are line, you can see, these are fault, line to line, again to ground. This is line to line to ground fault, line to line to ground fault. This one is a line to ground fault, a line to ground fault, and this one is line to line fault. You can see them. These are type of three fault in a three phase: a line to line, double line to ground, and a line to ground fault. Let's continue with our sequential. We have a zero phase. In a three phase, we have a zero sequence, negative sequence, and a positive sequence. As well, you can see that a zero phase, a zero sequence is given by IR equals to a third. A third what? Current at red plus current at yellow plus current at blue. That is the expression for a zero sequence. Expression for a negative sequence is given by IR2, that is negative sequence, and is given by a third current at red phase plus a current at yellow phase plus a squared current at blue phase. That one is for a negative sequence, and we have positive sequence. Lastly is a positive sequence. IR1 is given by a third current at red phase plus A squared current at yellow phase plus A not current at blue phase. But please note that this A is given by, that is we can say a displacement at 120. A is at 120 degrees, A squared is to 40. As you can see, it's given like this. You can see something like this. We know that this one is red phase, this one is blue, this one is yellow. The distance between this one and here, this distance is given by A and equals to 120 degrees. That is A. Another one is A. So A times A equals to A squared, and is the same as 120 plus 120 equals to 240 degrees, and A equals to 120 degrees. A squared equals to 240 degrees. So the A that you see here, A squared, this is a distance of 240 degrees, this is a distance of 120 degrees. Let's proceed and derive this equation. We can use, as well as, let's use a matrix form. And in a matrix form, we know that current at red, current at yellow, and current at blue. Don't forget this is a three-phase. In a matrix, you have 1 1 1 1 1. A squared A. Remember, A is 120. A is 120. A squared is 240. Multiply by our sequence I naught, IR1 and IR2. I naught if Z is given by 1 1 1 1 1 A squared A and A squared. If Z is that, then Z inverse we interchange should be equals to a third. You see here, this is a row. So we change row become our column. And if we change a row to become our column, we do this. We have 1 1 1 1 row become our column. So we start with 1 1. We start with row become our column 1 1 1. We are going to have A squared 1 A squared A. We are going to have one like that. So we come back to our equation and say that, let's continue. We are going to have IR naught IR1 and IR2. Remember, R0 is zero sequence, R1 is positive sequence, and R2 is negative sequence. Should be equals to inverse of our resultant is this. Take that 1 1 1 1a squared, then 1a squared a, and a third, our z inverse, a third multiplied by z inverse, we multiply by red yellow blue, current at red, current at yellow, and current at blue. Current at red, current at yellow, and current at blue. As you see, this one, let's take the first one. We note that IR0, remember this is our zero sequence, is given by a third multiplied by this times this, 1 times this, and 1 times this, and that will be a third. 1 times red itakuwa to I red plus 1 times current at yellow itakuwa plus I yellow plus 1 times current at blue face plus I at blue face. You can see this is a zero sequence is given by that, and here is the same zero sequence is given by the same. You can see it is the same. Let's prove for this is a zero. Let's go continue, and we are going for a positive. This is a positive sequence, and positive is derived IR1 times a third, this one times a third, that one multiplied by red, yellow, blue, multiplied by red, yellow, blue, and here we have IR1 is given by a third, given by a third. So a third, let's multiply this. We are going to have 1 multiplied by R1 will be IR plus A multiplied by IR at yellow, it will be I at yellow plus A squared multiply I at R blue will be A squared I blue. That one is a positive. Again, you can confirm here. You see this one is given A squared IR plus I squared I yellow plus I at blue. At blue face. You can see what is happening here. Then lastly we have a negative sequence, and negative sequence is given by IR2. That's a third multiplied by this. You row multiply column. Remember, row multiply column, and we are here. Let's start this multiply by that will be a third bracket 1 multiplied by IR will be IR plus A squared multiplied by I yellow will be A squared I yellow plus A multiplied by I blue will be A I blue, and this one is given by that. You can see that is solved using a matrix. And it is done by that. You can prove this sequence. Remember that A is the displacement. A is equals to, you also remember NB. You have to remember that A equals to 120 degrees. A squared equals to 240 degrees. Thank you for watching, and this is how you derive a zero sequence, positive sequence, and negative sequence. Thank you for watching, and welcome back. Thank you.